Thanks for having us here today. We're Duke Robotics. We're a club of electrical, computer scientists, mechanical engineers, graduate and undergraduate students here too. I'm Logan Ripper. I'm a sophomore, co-president of the club.
I'm Andrew Bowie. I'm also a sophomore and co-president of the club.
I'm Tom. I'm a sophomore and I'm the webmaster.
I'm Mark. I'm a sophomore and I'm the vice president with industry relations.
I'm Ryan, also a sophomore, vice president of finance.
So our club's mission is to take on large competitions and win. We have quite a legacy here at Duke. We've been around for more than a decade. We've been to the largest AEB competition in the nation 3 times and have gotten 4th, 3rd, and 2nd place. So our mission this year is to win AUVSI.
So we started off with the high altitude ladder project, as you see here. We started out with this with 3 main goals in mind. This is a transition project from what we were last year to what we are this year. Club with big goals, big aspirations. So this ladder here is actually going to go to 60,000 feet, where we're going to release it and have it come back to us autonomously. Only one other university has ever attempted this, and they have not succeeded, but we are confident that our project will succeed. We are actually going to fly this tomorrow in Chapel Hill, and so hopefully we can get some real success there. This club has, on this project, we are able to integrate freshmen and graduate students all working together. And we are able to work together as a team to finish up this project and hopefully work well. So
yeah, this project was all about building our team. So we're going to need a really strong team for this AAB project.
Yep. Right on.
So our next project for this year is in collaboration with Duke Makers. We're creating a full-sized humanoid robot based on the open source robot InMove, this one. So the robot will consist of a programmable webcam as a head, a movable torso, a mobile base which can be driven by a user with remote control, and arms which come with wearable sleeves where a user wearing the sleeves, the robot will reproduce any motions done by the user. This project has been independently funded and should be on track to complete early next semester.
Yeah, and there's a timeline for the project.
Yeah.
So I just added this one's kind of a legacy project we started last year, and so we're trying to wrap this up by the beginning of next term so we can focus all our resources on the AAB project. Speaking of the AAB project, we built a prototype starting last fall. We worked on an ROV, which is going to be probably the basis for our final design for the AAB project. The ROV is a remote operated underwater vehicle. We built this prototype so we could kind of get used to the unique challenges that working with underwater robotics presents. The ROV prototype has now been completed, and we've kind of driven it around in a little bit of water to get started. We got our feet wet, but we're not going to build the actual ROV until we finish this glider project, which we're wrapping up this weekend.
And we're using this platform to test our autonomous systems, OpenCV systems, which is computer vision that we're going to use to navigate through the autonomously navigable terrain, and then a system of integration with a set of sensors. So this is kind of like our proving ground for things that we're eventually going to scale up for the final competition. So.
Okay, so pretty much this year, all of our projects are large scale and they're high impact. As you can see, we have the high altitude glider, we have the humanoid, we have the AUV, and very importantly, we have the AUV-SI competition. Pretty much all of these projects we have deadlines for. We pretty much have solid planning for all of them, so I believe that we're going to be successful in all of them.
Yeah, one of our goals this year is definitely to be on track, be a really productive club, and crank these projects out on time.
And we would love to win the AUV-SI competition, and in order to do so, we need your support.
So what we're coming to you for funding requests for is the AUVSI project. This is one of the biggest projects we've ever undertaken. In the past, it's been incredibly expensive. We've managed with new technologies and new organization to reduce the price to about 1/5 of what it used to cost to enter this competition. In the past, we've won 4th, 3rd, in second, and that only leaves first for us to win this year. So feeling pretty good. Looking forward, Duke has realized the importance and the potential growth of robotics recently, and started to assemble a really strong team of professors, from bringing in Chris Hauser, George Conodaris, a professor that's been around, Michael Zavlanos, a really strong team of people. And the one common thing that unites all these people is the Duke Robotics Club. All these professors are in the electrical engineering department, mechanical engineering department, computer science department, but we've really managed to bring all these people together to work with us on these projects and advise us, and started to get them working together and communicating. I think that this time is a turning point for robotics in the world in a bigger picture, as the early 80s were for the personal computer, and we really need your help to help facilitate this change. We've been a leader in the past on campus, and we're a very strong group of leaders here, all sophomores. We're going to be here for the next 3 years to lead this club, and we're very passionate about it. Looking forward, our current makeup of the club, we're a very young club, but we also have the experience of older advisors and mentors. We've tapped 3 incredibly strong grad students and have interest from more that we're learning from, and fill in the gaps of knowledge that we don't have yet but are gaining rapidly. We also have an incredibly strong group of faculty advisors, as I mentioned before. And we really have an excellent team. Moving forward, after we complete this high-altitude launched autonomous glider project, which will be launching tomorrow morning at 9 a.m., we'll be devoting all of our resources in entering this AUVSI competition, which is arguably the largest autonomous system competition in the world. It's going to be this summer, July, in San Diego, and we're incredibly excited about it. And we really think that we're returning to our original mission statement by refocusing on large, high-impact projects that we really think that we can crush and bring home some glory for Duke.
And of course, we'd like to acknowledge all of our supporters here. Andrew mentioned our great faculty contacts we have here. We really have been appreciative of Duke and the way they've supported our club's growth this year. And of course, we appreciate you all today hearing our pitch.
What exactly an ROV and AUV do, or what are they?
Well, they're both underwater robots. An ROV stands for Remote Operated Vehicle, an autonomous underwater vehicle. In the competition, the robot we'll be building will complete challenges like going through hoops, shooting missiles, picking up targets, ascending in the water in certain rings. There's a lot of acrobatics and manipulation.
Completely autonomously. You put it in the water, press go, and it completes a really complex set of tasks.
Right, which is different from a lot of robotics.
On your budgeting slide, you said you had $11,000 requested for lab space. What is that lab? Where's your lab operating cost coming from?
Where is the lab physically, or?
Yeah, is it here or is it outside?
No, it's in FC Musser. If you go into that main auditorium, Shishiano Auditorium, to the left, there's a really nice open glass room. It's the Innovations Lab. It's shared by the Smart Home Robotics Club and IEEE.
And what's the cost associated with that?
Stock in the lab.
Consumables, electronic consumables, new lab equipment this year. We're trying to upgrade our power supplies and oscilloscopes.
The lab was pretty much put together like 10 years ago.
Yeah.
And hasn't really had the leadership to be reorganized or restocked for high-level projects like this. We have a lot of like small voltmeters and things like that, but to do a big project like this, we need nice oscilloscopes and things like that.
In the past, there's been a number of corporate partnerships that have supported the robotics program. Is that something that you all have been investigating with the
Absolutely.
engineering school?
Yeah, so we have actually reached out to a couple of companies right now, and we're still getting word back from them, but we are looking around to make sure that we have a steady supply of funding for these projects.
This year we completely reorganized our executive team, and Mark is taken on the role of Vice President of Outreach, which is his main job, is just going out to get funding from companies.
Very good. Thank you.